Hi, everyone. My name is Haley Driggers, and today I will be presenting my final project for the Introduction to Health Informatics. I'll be speaking on diabetes prediction using a machine learning model. This model is successfully deployed and providing predictions as anticipated. So first, I'll talk a little bit of the project background. I chose to do my project on artificial intelligence and a chronic illness, specifically machine learning and diabetes. And then my model focuses on several different features such as age, weight, and A1C results, for example. Diabetes is a well-known chronic illness. It's becoming more common in today's society, and it's starting to affect more and more people. So to help doctors accurately assess a patient's diabetes risk, we wanted to create this machine learning model to show how this emerging technology can be used in healthcare and how it can provide a difference. There were several things that I had to research for the project. First of all, the calculations of A1C results and how they are evaluated. A1C result is a measure of a person's average blood glucose levels, and it can help indicate if that person has diabetes or not. So for this, I use the explanations directly coming off of the data set and the way that they calculated it. There was also a research paper for the data set that it was based off of that spoke about A1C results. I used that as well. And then just to make sure I had medical backup, I did some research on the Cleveland Clinic website as well. I also had to research XGBoost a little bit and what kind of parameters that I would need specifically for this project. I ended up choosing multi-soft max with 3 classes. That's because multi-soft max, it's used for scenarios where there are multiple classification classes, and it provides a predictive label. And then I will be using low, medium, and high to assess this, which is why I chose to use 3 number of classes. So before I get into the demonstration, there were a couple of key points that I wanted to go over. The data set that I will be using is a diabetes data set from the UCI machine learning repository. I'll be using Python strictly as my coding language. XGBoost, as I mentioned before. I'm using several AWS services, SageMaker Notebook, and an endpoint, a Lambda, and an API gateway. And for testing purposes, we'll be using Postman. Okay, before we get into the implementation status, I wanted to give a demonstration of my notebook. So this is the notebook that I built out, contains all the code. This is what builds the model. Up at the top, we just start out installing and importing all of the packages that we need. We get directly into pre-processing, loading in those data sets. It initially came with 2 data sets, but I combined and merged those just for simplicity purposes. So there were also a lot of feature columns in this data set, and a lot of them didn't necessarily apply to what we were looking to accomplish. So I just dropped a bunch of those columns so it would be more focused on the outcome and the results that we wanted. So we're going on doing more pre-processing, lots of pre-processing going on. There were a lot of special characters, curly braces, brackets, parentheses that didn't match up with each other. I was throwing tons of errors, so just dropped all of those just to provide some simplicity. Dropping null values that are left in the data set. And then this is the A1C result calculation that I had spoke a little bit about before. Here I'm creating the custom mapping for that, creating a new target label for that, saving off the new data set, printing out those columns to make sure everything is looking good. And then I created those for low, medium, and high. And it turns out that the model would not accept those. They had to be int data types or numerical labels. So we had to encode those to be 0, 1, and 2 for each one. Then just doing some more print statements just to understand exactly what's going on in the data set. Here we're doing some one-hot encoding on some of these specific columns here. Taking out some, again, more special characters that were throwing errors. So down here, we're splitting the data with all the columns versus that target variable that we created before with the A1C result. Then we're splitting that data set. Training that model, saving it off. Again, printing some columns to better understand our data set. So down here, we are creating that model.tar.gz file and saving that off into S3, also our local environment. Here we are creating that XGBoost model and deploying it to an endpoint. So let's jump over here. I can show you the endpoint that we have here. I have several up, but we're going to use the most recent one here. There really isn't anything to see here other than the endpoint that has been created. So let's jump over to our Lambda function here. Just to walk through the code again, very high level. Just doing our imports, doing some more custom mapping here. So as I mentioned before, we had to do the label encoder on those A1C results that we calculated. But in the response, it was returning the 0, 1, and 2, which didn't make much sense to the user. So created a custom mapping for that to replace it as low, medium, and high, just to have a better understanding. Invoking that endpoint, and this is the endpoint name that I had just showed you. And then down here, doing the prediction, and this is what it's going to return. So from here, we can go over to Postman. I can show how that works. We want to do a post request, and this URL here is the URL off of my API gateway that I created. And this is the body that we will be passing in. Basically, it's saying that it's a Caucasian male, age 40 to 50, weight 125 to 150, 3 days in the hospital, 43 lab tests that were done. It's not taking any current diabetes medication or anything. So if we send that in, we'll get a risk level of low and a risk score of 0. So based on our model, that aligns with what we were looking for. So right now, let's go back to our slideshow. So for the implementation status and future work, as I just showed, the model is deployed successfully, accurately does predictions and gives responses. For future work, there are a couple of things that could definitely be made better. I think one thing is we need to update the API request body and the response. So as you saw, it's basically just a long string of numbers. And all those numbers are explained in my documentation, and it will walk you through what each one of those numbers means and stands for and what they should be. That isn't very user-friendly, especially for a doctor who's meeting with a patient at the moment. So just for a better user interface, I think those can be updated as well. And then, as always, further tuning and testing for the model can be done to make sure that it's up to date and the results are still being returned accurately as we expected. That concludes the presentation and the demonstration. Thank you so much for your time.